Okay, so again, all of the keywords that we've looked at are super important, and we've met acute angles, and this is called angle B, or angle, so I can call that angle B, or I can call it angle ABC, so the one in the middle. This one here is a right angle, and it is 90 degrees exactly. This one here is an obtuse angle, and it's more than 90, you can see, and it's less than 180. So this angle here is angle H, or it's angle GHI. Okay, so again, the one in the middle, if you're writing the three letters. This is angles on a straight line add up to 180. Super important, okay, to be able to spot your straight lines no matter where they are and know that angles on a straight line add up to 180. This is a reflex angle, which means that this part here is less than 90, and so a lot of the time people will measure the small angle, and then as a result they'll be able to figure out the larger angle, and that's because angles around a point add up to 360 degrees. So really important, these two, for helping us solve angles later on. Okay, you might come across the keyword ordinary angle, and that's acute angles or obtuse angles, could be called ordinary angles, and also null angles as well. Okay, so here I'm given two questions and I'm asked to solve for x. So to solve for and a keyword here, unknown. So my unknown is something I don't know, and in this case I don't know what x is. I have to look at this with an overview of all of the things that I spoke about in the last slide. So all of those bits of information. So what can I see? Well, first of all, I should be able to spot that x is actually an acute angle. It's quite small, so it will be less than 90 degrees. This angle here is 120 degrees. That's already marked in for me, and it's an obtuse angle. But overall, this bottom line here is a straight line. And I know that angles on a straight line must add up to 180 degrees. And I'm writing that piece of information up here just so we won't forget it. So I'm asked to write an equation, and an equation has a letter, numbers, and an equal sign. So I know that if I add 120 degrees, if I add it with this x here, I should get, because it's on a straight line, I should get 180 degrees. And at this point, what I'm going to do, first years, is I'm going to solve for x, which means I want x on one side, everything else on the other. And so that's going to fall into letters equal numbers, which means I have this 120 degrees here, and I would like to get rid of it. So I'm going to do minus 120 degrees here, minus 120 degrees here, because obviously, as I know ourselves, what I do to one side I must do to the other. They're going to go, and my new line of the equation is going to be x equals (180 minus 120 is 60 degrees. Okay, I've just given myself a little bit more room now to do the second one. So the second one here, I'm given three different types of angles, and obviously this one in the purple is the one I'm looking for, the x. And I'm going to zoom in at this point here, because this point here is a point, and I should remember that angles along a point add up to, or around a point, add up to 360 degrees. And this is the information that's going to help me solve question 2. So I know that if I add 180 degrees plus the x plus the 25 degrees, I should get 360. So 185 degrees plus x plus 25 degrees should give me 360 degrees. This will help me figure out my x. Again, I'm going to follow the same method as letters equal numbers. I'm going to place that here. Is there any type of tidying up I can do at this point? Have a look at the question. You have 185 plus x plus 25 equals 360. Can I tidy up? Can I, and the key word is, can I group anything? And hopefully you're spotting that you can actually group the 185 and the 25. So if I was to add them together, that would give me 210 degrees plus x equals 360 degrees. And again, I want numbers equal letters or letters equal numbers. So I'm going to get rid of the 210 degrees, and just like the balancing, I'm going to do this by adding a minus 210 degrees, and what I do to one side I must do to the other, and you'll notice that your 210 degrees is gone, and now I'm left with x equals 360 minus 210. You can use your calculators for this one, but it should be 150 degrees. Okay, so what we're looking at today is we're looking at finding angles that are unknown. Now, normally when we talk about unknowns, we refer to them as letters. And so here I've got a straight line angle. I know that this part here is a right angle, and I've got the symbol for right angle here. And I'm told that this part here is 7x, and this part here is 2x. So these are unknowns, and the unknown is x, and I am asked to solve. So create an equation and solve. So I suppose first of all we have to go back to what is an equation. An equation is an expression that contains an equals, and an expression is a mixture of letters and numbers. Okay, so we're asked to create an equation, so something that is letters, numbers, and an equals. So let's go back over and have a look and see exactly what we have. If I examine this, I can get a lot of information. First of all, I can see that this angle here is going to be 180 degrees. So I'm just going to move that a little away. It's going to be 180 degrees because it is, of course, a straight line angle. And I know angles on a straight line add up to 180. So essentially, I know that this plus this plus this, it has to be 180 degrees. So I'm going to write an equation to show this, and it is 90 degrees plus the 7x plus the 2x has to give me 180 degrees. Okay, that is essentially all my hard work done, because what I have now is I have an equation. An equation is very similar to what we did in the whole last chapter, and we're going to follow the same method. First things first is I've got 90 degrees plus 7x plus 2x equals 180. So I'm asking myself, can I simplify anything here, or can I group? Perhaps a better word would be group anything here. So I've got 90 degrees plus 7x plus 2x plus 180. And hopefully people are spotting that I can add the 7x and the 2x because they are like terms. So it now becomes 90 degrees plus 7x and 9x gives me, 7x and 2x gives me 9x equals 180. And at this point, first years, I'm now going back to the very start of algebra, solving equations, when I follow the Sippen method of letters equal numbers. So on this side of the equals, I just want letters, and on this side of the equals, I would like the numbers. So if I have a look, I have 90 degrees plus 9x equals 180. So from examining that, I can spot that the number 90 is on the wrong side. So I am going to get rid of it. I can get rid of it by balancing. So I have a minus 90 here, minus 90 degrees here. And then obviously I'll have to do the same to this side, so minus 90 degrees here. So my 90 and my plus 90, my minus 90 and my plus 90 will cancel. And I'm now left with 9x equals 180 minus 90, which is 90. Now, I have successfully done my letters to one side, numbers to the other. And at this point then, I'm trying to solve for x. Remember, this is 9 times x, which essentially is 9 multiplied by x. I'm not interested in 9x, I want to find out what x is. So I'm going to get rid of the multiply by 9x by dividing by 9. But remember, what I do to one side, I must do to the other. What I'll find is my 9 goes into 9 once, leaving me with 1x, or more commonly known as just x, is equal to, and 9 divided into 90 is 10. So I now know that the x stands for 10 degrees. Let's go back up now and have a look at my question. And it was that straight line here, I had to find out the number of degrees for this part here and the number of degrees for this part here. I now know that x is 10 degrees. So 2x, to zoom in here, 2x would be, 2x means 2 multiplied by x, so it would be 2 multiplied by 10. So this here stands for 20 degrees. And that is an example of an acute angle. So anything less than 90 is an acute angle. And then if I was to have a look a little bit further at the 7x, so I figured out that the x is now 10 degrees, so 7x means 7 multiplied by x, which would in turn be 7 multiplied by 10, which is 70 degrees. Which is again another example of an acute angle. And if I was to zoom out, we can now have a full look at that question. And I'm saying that this is 90 degrees, which was already marked by the symbol of the right angle. I figured out that this now stands for 70 degrees, and this here stands for 20 degrees. Now my diagram is not drawn to scale, so just be aware of that. So I've now solved that question, and we can do a little bit of a check to make sure we're right. So I'll do the check on this side here. So it is 90 degrees plus 70 degrees plus 20 degrees. I am saying that if I add those three numbers, I should get 180. So let's check. So 90 and 70 is 160 plus 20 is 180. And therefore I am correct. So you can do a little check at the end just to make sure. Okay, so tonight's learning check, you have 4 questions. So 1, 2, 3, 4. And you are asked to create an equation. So remember, equations have letters and numbers and they have an equal sign. To represent the following and find the size of the angles marked with the letter. So you can see here, this is going to be talking about an important point I mentioned earlier on, that angles around a point, and if I zoom in here, this is our point. So angles around that red dot, they must add up to something, and that's going to help you solve that question there. The rest of them should be fine. Have a look at this. What information can we gather from this? What is an important fact about angles that we can use? And also, what is another fact about angles we can use here? And if I zoom in here on X, you can see that that clearly is a point. So, helped you out a lot there. And the last one is very like the example I've just done. So you just need to have a look there and see, can you come up with an equation that will work for this? Remember, an equation has letters, numbers, and an equal sign. Okay, and I'll see everybody tomorrow.